The third is a cash transfer model, which has been tried in Rajasthan, and there is a pilot study which was done in Delhi with some results. Cash transfer model which has given money. The next one is the food security bill, where you actually give a whole lot of nutrients and other things to the end market. And the fifth thing, which is not being talked about, but which is probably all these things which we talked about, are the food coupon standards. The issue is, we guys are not policy makers. We guys are students or an economics. We are not going to say which one is better. What is their fair analytical framework to evaluate them? That's my focus. I'm not going to say what is good, what is bad. I cannot say what is good or what is bad. But let's see what is a good analytical framework which can help me understand which one can work better. That's my focus. So this is the issue, that's my focus. And my argument is that last part of the consumer thing which we are starting with is the first. We allow it to have a go at it first. So that's what I'm going to do. So what I'm going to do next is, I'll just try to briefly explain this in how the economic one-on-one consumer theory independent work. Once we are clear of things there, then we will take up each of these issues and see which one is going to make difference. So that's what I'm doing. Are there any questions at this stage which you want me to ask? Yeah? Is it okay? Okay. Reading. What are the readings apart from your textbook on what you're going to understand? You go and do Google and find out all these stuff and just try to read it. Okay? And just form some information about what these are, and then try and go back and see how can I analyze them in a particular case. So there are many things which we will not be able to analyze. Targeting will not be able to analyze. Corruption will not be able to analyze. The argument is we will try to bring corruption and see what can be solved in the later phase. Now I cannot focus on that. Maybe at the end of the question on that I will try to answer. Now, there is also what is called, I don't know, it is called something. There would be something called a researcher's bias or a professor's bias. So there could be one model which is more closer to the guy who is giving the lecture. So he or she will have that bias. I may have a slightly higher bias on the cash transfer. Okay? Simply because there was some part of the cash transfer to which I was involved somewhat. So, and because I was involved somewhat, because I thought that that's a good model, and therefore I twisted because it's to prove it's a good model. But I try to be as objective as possible. What will be the good and bad. So let's get to this basic microeconomics. Okay, so this is the problem. So how do I solve it? So the first, we are going to say that individuals have what we call utility functions. Let us draw it like this. It's a two-dimensional utility function, which means that this is x, and if you've got utility as a function of x, then most likely as you consume more of it, it is going to go up but at decreasing rate. That's what you have done. That's for one particular good, right? So if you had another good, it's a y. So how would that diagram look like? More or less the same thing, right? Absolutely no reason for most goods x and y, so to increase utility, sorry, to increase the consumption, utility will go up, but at a decreasing rate. There are goods for which as you consume more, the utility is going to go down. The pollution is one of them. Okay? But we are looking at the normal good. Now, this is x y. If I look at the utility surface, how will it look like? Can you visualize the utility surface? That's a three-dimension, right? X here, y here, and utility surface, utility on this side. How will it look like? Let's see how you can visualize. How does it look like? Very simple. This is the origin. That's x, this is y, right? How does the x curve go up? It goes up like this. How does the y curve go up? It goes up like this. How will the x, y curve go up? So as you're moving out, it is like this, like a mountain side, right? It goes up like a mountain, right? Can you visualize that? So because that's the plot, you get having to research. Fair enough? So it kind of goes up like this. This is the curve. So I think the best way to visualize that is for the time being, let's have this graph. And if you do the x and y plane to the with this. That's how it will go up, right? Not this portion, but the going up portion. Now let's talk about following. What is the, when you get all the X and Y combination which is the same level of utility, how the gas combination looks like? It's a mathematical term for it, right? That's for the local. X and Y. All X and Y combinations give the same level of utility. Visually what does it mean? Okay, let's see the utility. Whatever is the height. What is X and Y utility? What is X and Y combination which gives you the same level? I start walking, I hit the mountain somewhere. Same height, right? So along the edge of that mountain, the surface, all the combinations and X and Y will give you the same level of utility. Fine. How did I prove that? It's a U. Are you okay? I getting it. If I increase it slightly, what happens? If earlier this where I got it, if I increase it, I have to walk 2 steps. I hit the mountain, how will it look like? Another U. So as I move away from the origin, the concentric circles go up, and each of these curves is building higher utility. Let me plot that in the 2 diagrams. So let me say your X and then this is Y. So how will the curve look like? And each one of them will have higher utility than the other. So that's 30, that's 20, that's 10. So what does it mean? That suppose there is utility level of 30. Those are the combinations of X and Y which is 30. What 20? Those are the combinations of X and Y which is 20. That's the one which is seen as isoquants in the reduction function. Right? The question which you are asking is, if you have a reduction function, what are the combinations of X and Y which give you the same level of power? The question I am asking is different. No? If you have an X and Y, so if you have a particular level of utility, I am not in the answer what does 20, 30 mean. You leave that aside for time being. What are the combinations of X and Y which is the third one? That is not that will be defined. Now let's look at the following. So, take the term, diminishing marginal rate of substitution, that is figure out what means what. I have to kind of get to the answer as soon as possible. Okay, if I ask you, don't have to pay for it. How much of X and how much of Y will you consume? What will be your answer? You don't pay, I will pay. How much of X and Y and how much of Y? X and how much of Y will you consume? There won't be any answer, right? Because the more you move, more and more utility, and then you will keep on going. So how do I use this? And so, but if I change the question and say, okay, if I let you pay, how much of X and how much of Y will you consume? Now, tax says, then you get the budget line, right? So what's the budget line? This is the budget line. How would I got it? The budget line will be a negative slope. That's fundamentally, this is constant, right? That's a negative slope. And the slope, the dy dx is given by minus dy by dx, minus dy by dx, right? dy dx? No, minus dx dy. So how do I mark this? So what is going to be this particular point? Which is going to be minus dy times y by dx. How did I get this? Okay. So suppose dy is equal to 0. Sorry, let's put this. Suppose you don't consume any amount of y. You decide I want to consume any y. What is the maximum amount of X can you consume? N by 2. 7. You have to think this. Suppose I don't consume any amount of X, how much of y will you be able to consume? That's N by 2. So that's the budget line, this is the utility. What does the basic diagrammatic exposition of the 4 examples tell me? How much will I consume? I will try to consume so that I get the highest possible utility. I would ideally like to be somewhere here. I cannot because my budget doesn't permit me. I can be somewhere here, but I don't stop there. Because I can actually be on a curve like this, which is higher utility than this. That curve is 12. I don't know what the number is. Which is just about my budget permit, and my utility and consumption will be Y star and X. That's the basic microeconomics. So that's the Y star and X. Now, one exercise which you can try and do is, if you have a top-down production function and if you solve this particular problem, you will be definitely able to get the demand for X in terms of the income, maybe price of Y, maybe price of X, so on. That's one way of looking at the utility function. Now, indifference curve, some indifference curves can be like this, all of them. Some of them can be like this, some of them can be flat. What will determine that? Utility function. Are you okay with this? I'm just asserting something without proving. I'm saying that I only thing which I know is that the indifference curve will be like this to the origin and it will shift up. But the exact slope, shape, etc. can be one of the various ways. I don't know if you can read now. Let me just wait for the power. So the purpose of the utility pattern is over. So I can read over. Can you see the book? Right, so here is what analysis I'm trying to do. So I know that indifference curves are still parallel to each other. Take it from me. You can do the proof. You can probably intuitively figure out why. So the indifference curve can be anyone. It can be like this. These are the cases of indifference curve. All the indifference curves can be like this. All the indifference curves can be even like this. So which one? That depends upon the original utility function. Irrespective of utility function, I know the curve will be like this. That's all I can say. That's an important observation. Right. The original utility function. What determines what kind of utility function will it be? That's an important thing. Right? So there are two possibilities. At this stage, there are multiple. I will bring at one.